All right. Think I got this working, yo. Just gotta make sure everything's all set up and ready. Gonna check on remind, send a message to everyone. All right, I hope it's sent. All right, there it goes. We got 4 people on right now. If you're watching the video, go ahead and just say hi in the chat just so that I know who's on. And then that way we can kind of just, keep track of what questions we need. I figured we could start on the first review packet first. Wow, redundancy. The green packet for all of you following along. All right, I got Alonzo, I got Liz. What up? I got Bella. Isabella. I have like 5 Isabellas in my classes. Way too many to count. What's up, Natasha? Zach, my day is going well. I hope your day is going great. What's up, Catrice? I got Kyle in the house. He says hola. 15 viewers. Wow. Okay. It's looking good. Very promising. What's up, Lily? Why don't you all go ahead and just start throwing some questions out there, and we'll just kind of go through. If you need me to redo any problems or have any questions on any specific parts of problems, just let me know. I don't mind doing it over. I can give you guys until probably 8:30, and I want to try to get some sleep because we got a big day tomorrow, and y'all got part of your final to do. It's not going to be bad. We'll go over part of it tomorrow morning too. I do want to go over 2 questions specifically tomorrow that you will be asked that we didn't get to go over. Number 8 on the first packet, 8 and 9. I assume those are going to be on the green packet because, of course, my iPad doesn't show that. Okay, 1B. Yes, I will get to that, Natasha. Okay, so we learned about congruences and similarities. So the biggest thing to really understand is what makes shapes congruent, right? Shapes are congruent when all sides, and specifically we're talking about the corresponding sides, are congruent, and all angles are congruent. And remember that wrong ones. Oh, you're saying on the first packet. I was gonna do just the free response stuff for now, but if we have time, we'll jump into like the other colored packets. For now, I'll do 8 and 9 on this one, and then we'll go from there. So remember that when we had triangle congruences, we had our 5 postulates. We had our side, 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 angle, angle, side, angle, 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 side, and hypotenuse leg. Jeez, I cannot write. Right, so if we're drawing a picture to show what it means for kind of an example, like let's say we did have, triangles. right? Here's an example of a side marking, right? Just kind of straight out. What's up, Logan? What's up, Jake? Or if we want to look at any of the other ones, side angle side, right? You could have one side, two side, and the angle in between. You could have yet again another side marking, angle, and the other side marking. So again, as long as there's consistency with whichever one you work with, that's totally fine. Now, the biggest difference between congruency and similarity, the angles still have to be the same, but the sides now have to be proportional. And of course, remember that things that are similar, you know, if we took a model boat or a model of a building, and usually there'll be a legend that says that every inch on this model represents 100 feet, right? Proportionally, this model is the exact same scale as the original. So all sides are proportional. But of course, the angles still have to be preserved. So all angles are congruent. Now, when we talked about triangle similarity, we only had 3, and they're basically the same as the first 2 that we had here with the addition of angle, angle. So side, 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 angle, side, and angle, angle. Right, those were our 3 that we had for similarity. Now, to illustrate this a little more appropriately, right, the shapes aren't the same size, they're proportionally the same shape. So in this case, let's say I'm dealing with the side angle side. Let's say I have a 3, some angle, and then a 4. Well, if I want this to be similar, let's say I triple each of the side lengths. This would be 9 and this would be 12. Right? These two are similar. Oh, Gianna's at the store. I'm sorry, dear. There'll be, I made sure to click the option where this video saves. So you can watch it back later if you want. I got you covered this time. Yeah, I don't like YouTube changed its stuff from the last time I did this, so my apologies, children. So yeah, that's 8 and 9 on this one right here, Isabella. Hopefully that was helpful to you. Natasha, I'm going to help you out with 1B. And I'm sure maybe a couple of you also had that. Yeah, Alonzo, you had that too. So we take a look at number 1B. Right, we have to work our way through these triangles, through these angles. One thing to note is that in this one, yes, you will have decimals in the angles. It just happened to be that way. That's not always the case. You guys have seen most of our angles have been, you know, whole numbers. So no issues there. It's not a big deal if we have decimals here too. Okay, so first thing I'm probably going to want to do is highlight some of my triangles I'm working with. I'm working with this triangle here, the big one. I'm working with this triangle here, the other big one. And then we kind of have that triangle that's inside overlapping between those two. The green one might not be a good color. It works out fine. So that green triangle, I have that 90 degrees right there, which is actually very useful because if you look at the angle markings down here, because those two need to be the same angle measure, that makes this triangle isosceles. So what we can say is 180 minus 90, which gets us 90, split that in half, that's 45. To answer your question about the compass, you do need a compass for one of the questions on your final. I am going to go over that question before you take it. If for some reason you don't have a compass, it's fine. You can borrow one of the ones that I have. Lizzie, the free response packets, I decided, yeah, you could turn them in for extra credit if you want. we can make it so that it's 5 points for each packet you turn in. And again, like I've said, I need to see all work shown. Otherwise, if I find one mistake, and I mean, I know where the mistakes will be, or if I don't see work shown and I just see answers, I'm just going to toss it in the trash and you won't get the extra credit for that. Okay. So anyways, back to this. So on our orange triangle there, I've got the 70, the 45, and angle P. So I'm going to probably solve for that one first. $70 plus 45, right, 115. And then we're going to take 180 and subtract that. And we get ourselves a nice 65 degrees. You're funny. All right. We're going to look at our yellow triangle. Same thing. We have the 45 degrees there. We're going to add to it the 83. We're going to subtract that from 180. What up? Thank you. Why can't I math? 60, 52. So that's 52 degrees. So angle S. Okay, so now we're going to look at the angle right up here. Yes, you need to have 1B done. Oh, you're talking about for the second one. No, that one was a challenge one. Don't worry about that one. I'll be nice. Right here, Natasha and Alonso, angle N forms a straight line with this angle here. So that means that N plus 45 has to add up to 180. If I take away the 45 from 180, we get 135 degrees. And again, if you guys are coming in late, just make sure you just say hi so that I kind of know that you're here. Most of you did, so that's good. I have 21 of you here. That's almost a third of the class. We're going to use the vertical angles here and get the 45 degrees right in that corner. And again, we're dealing with another isosceles triangle. Blue on blue might not be good, but it might turn out better on your guys' screen. I'm going to actually take a look. 3, 2, 1. Okay, yeah, no, it's coming out good. I'm just counting the delay. All right. Yeah, it's not too bad. So we're going to do 180 minus our 145. Why did I say 145? 45. 135. And we're going to take that and split it in half. So that's 62.5. Right? No? 67.14. Yeah, 67.5. There we go. Much better. Okay. So angle T is 67.5 degrees. Now we're only left with angles R and M. So angle R forms a straight line with this angle here, which is the same measure as angle T. So 180 minus 67.5. So that's 120, no, 112.5. 112.5 degrees. So Charlotte, so for all the extra credit packets, any that you turn in are the only ones I'm going to check. For the second extra credit one, or the second free response one, the challenge question, which is 1B, you don't have to have that one done because, again, that one was a challenge one. But have everything else done. What did we say? Okay. Now we got to solve for angle M. Now I know that I have that triple angle mark. Ooh, okay, the triple angle mark is also down there. That's a 70 degrees. So we can take the 45 and the 70, and again, I'm looking at this triangle right here. 70 plus 45. And then we're gonna subtract 180 from, or 115 from the 145. So M is 65 degrees. Boom, all done. Okay. Not too bad. Yes, it is a lot of little steps, but you should have no issues with just doing the triangle properties, the straight line properties. They're practically the same number anyways. So don't overthink it. I just hope I'm not getting sick, because otherwise it's not going to be good for me, because I want to go to San Diego this weekend. Where did I get the 45? I'm assuming you're talking about the 45 that's kind of tucked away in that little corner there, Sydney, in the light blue, because I'm looking at the pink triangle. Let's see who else messaged me. Do, 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 do. Do, 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 do. How'd I get angle S? If we looked at the yellow angle, the yellow triangle, I mean, we use the 45 that's on the right side here with the 83, and then we subtracted that from 180. Why isn't angle N 45? That's because 45, Zach, is outside of the triangle, and it's where that purple is. I formed a straight angle with the little 45 there. So 45 plus 135 gets me 180. Exactly, Jake. It's not vertical from it. Way to use our vocab, guys. I love it. Okay, so Alonzo and Natasha and everyone. Okay, we'll jump to 3 since that's kind of on the next page. Then we'll jump to 5 and 7. You guys are funny. All right, 3. Got some parallel line proofs here. So AB is parallel to MC. So I'm going to draw my arrows there. Parallel doesn't mean they're congruent, so please don't mark them congruent. Also, some of you guys still aren't marking your triangles. Please mark them. The colored packets are due the day you take your final, which would be not tomorrow. It would be for period 5 on Tuesday, periods 3 and 7 on Wednesday. And unless for some reason you did not take your final on any of those days, right, you have to make arrangements with me, but they are due that day, no exceptions, because I've got a lot of stuff to look through. Okay, the only other thing I know is that M is the midpoint of AD. So here's my line AD. M is the midpoint. I'm literally placing a dot on that line. And what I'm going to end up doing, I'm not going to write the givens. You guys are going to write those. But I'm going to mark that AM is congruent to DM. And you could say MD, it doesn't matter. Why are they congruent? Well, we see the word midpoint, so we're probably going to use the definition of the midpoint. If you just write definition of midpoint, that's totally fine. What's texting me? My friend's funny. Okay. So we have that. We haven't done anything with the parallel lines yet, so let's go ahead and use those. If I'm looking at just the yellow lines and I make this bottom green line my transversal, then you'll notice that angles 1 and 3 are in corresponding positions. Well, as soon as I say the word corresponding, I better be thinking that they're congruent. So angle 1 is congruent to angle 3. Now, I know they're corresponding. If I happen to have other corresponding angles, let's mention them on the same line. And it so happens that, yes, I do. I have, for the orange lines and the green line, angles 2 and 4 that are corresponding. They're in the same position, right? So we can say angle 2 is congruent to angle 4. Corresponding angles are congruent. Now, I've marked off my side. I've marked off an angle and another angle. Oh, would you look at that? Angle, side, angle. So let's go ahead and say now that our triangles are congruent. Now, I do have a question for y'all, and I know it'll take a couple of seconds, but I want to know for this proof, are we going to be using CPCTC? That is a big question. Just say yes or no. You don't have to give any explanation. Just say yes or no. And then we'll kind of go from there. I want to make sure you guys know exactly when you're going to do CPCTC. It's so funny because if you go and look at all of my older videos, I don't have long hair at all. It's just like super short. Yes, we're getting all the no's. And yeah, we got to make sure that we know that if you're proving the triangles are congruent, you're not using CPCTC. If you're proving something else is congruent, like angles or segments, then yes, you would go ahead and do CPCTC as your final step. You still have to show the triangles are congruent, but you're fine with just at least knowing, hey, I know that this has to be my last step. And yeah. Okay, so I am done with the proof. I think we said we were going to do number 5 and 8. I have to scroll up now. I see all the notes. Good job, y'all. 7 and 5. For some reason, I thought we said 8. Oh no, that was like way earlier. Okay, 7 and 5. Huh. I did that one already, but I can redo that one. No biggie. 7. And I just said 5, didn't I? Oh, 5B, that's right. Okay. So right here, angle 1 is congruent to angle 3. This is my given. I want to show that the lines are parallel. So I'm going to need to, do some work here. Angle 1 is congruent to angle 3. That's our given. Based on the drawing, if I look at what I know for... what was I saying now? Total like goldfish moment. I know that these angles right here, when they're across from each other, those are our vertical angles. So we're going to say that angle 1 is congruent to angle 2. This is our vertical angles are congruent. So I'm going to mark it in my picture. Now, I'm trying to show that A and B are parallel. So I can't just say 2 and 3 are congruent because they're corresponding. I have to use the fact that because they're congruent and they're corresponding, the lines are parallel. But I have to first establish that 2 and 3 are congruent. Well, how are we going to do that? Well, I kind of came up with a little kind of, I don't want to say trick necessarily, but kind of a little thing to help us out here. So 1 is congruent to 3 is what we started with here. So if I write it out, angle 1 is congruent to angle 3. If I take my second statement, I can't just put this right here. I can't just tack it on at the end because my statement doesn't start with an angle 3. It doesn't say angle 3 is congruent to angle 2 or anything else. It says angle 1 is congruent to angle 2. So instead, what I'm going to do is I'm going to move it to the front because that's where the angle 1 is. So angle 1 is congruent to angle 2. And so now what we have here is a scenario where it's kind of a middleman situation. We have, angle 1 that's common to both statements. So all we're going to do is we're going to kind of drop it. And now we say 2 is congruent to 3. This is our example of our substitution. It is not transitive. I'll show you guys in a bit what transitive would look more like. If we had angle 1 was congruent to angle 2, and angle 2 is congruent to angle 3, if I were to write that out in a line, and then notice that I can start this one right here. Well, right there, it's one giant line. It's just one giant logic flow. We can skip straight from 1 to 3. That's the transitive property. So that's why we don't do it here. For this one now, we're going to say that A is parallel to B. That definitely didn't look about equal. This one is if corresponding angles congruent, then lines are parallel. Transitive is if we say if you go from A to B, B to C, therefore A to C. Transitive is a very specific type of substitution. It's, more straightforward. It's more, I can go from one point to the other versus here. I know 2 things are true about this angle, but they don't directly lead to each other. I just know by association. All right. Yes, we can get to number 12, Jimena. I gotta remember we just did 5B. Yep, just did 5B, so I think now we're on number 7. And I know we already did that, but that's okay. We'll do 7 and 12. Okay, so we're looking at our glide reflection here. This glide, when you look at this, you have to know that your x's tell you that you're moving left or right, and you have to know that your y's tell you that you're moving up or down. Because this says x minus 2, this is telling me to go left 2. So I'm literally going to move all of my points to the left. Did I say 2? Yep. 2. So Daniel, yeah, we can't say that the lines are parallel because the angles are, hold on. We can't say that the angles are congruent because the lines are parallel. We have to show that the lines are parallel first by showing that those angles are congruent, and because they're corresponding, it shows that they're parallel. So right here is A prime, B prime, C prime. Please don't forget to connect the dots, and don't forget your notation. Now we have this reflection. Again, just, knowing, hey, x equals. I know some of us still get confused, like, oh, well, the x-axis goes this way, right? But you're telling us to draw the line this way. I know it can sound a little counterintuitive, but let's think about it. If I take x equals 2, let's just pretend I make a table. It doesn't matter what point I pick, the x value will always be 2. So let's say I pick y to be 0. Let's say I pick y to be -2. I can pick y to be +2. I can pick y to be anything, right? And so if I graph these points, if I go to 2, 0, or 2, -2, 2, 2, they're all going to be going straight up and down. And I just deleted my prime. Boom, there we go. Okay, so there's our line of reflection. We're going to go ahead and reflect the points over. So you're counting the distance. C prime is 1 unit away from the line, so I go 1 more unit over. So right here, C double prime. And it's okay that the point ended up there. It's not a big deal. A prime, 1, 2, 3, 4. 1, 2, 3, 4. So we would end up right there. Don't want those dots everywhere. I just use them to show you guys I'm counting. All right, and then we take a look at B prime, 1, 2, 1, 2, right there. B double prime. Alonso, I believe number 12 is the construction questions. Those are the things I'm going to go over tomorrow in class. I'm going to go over them first thing in the morning. So don't worry about that. We're going to definitely do 9, but there was the other one they wanted us to look at. No, that's basically it. Just did 7. So we'll do, well, I just did 9. Maybe you weren't here when we did 9. So I'll kind of leave it there on the screen for you for a moment. I'll help you out with 10, Alonso, no worries. I got you. My friend is ridiculous. He's so funny. Can I talk you guys through 8 and 9? Yes and no. I mean, really, you just have to know the difference between congruent and similar. Things that are congruent have to be the exact same. Things that are similar have the same shape, but have different sizes. right? And with our similarities, we had 3 theorems that we looked at. With congruence, we had 5, but you'll notice that 2 of them are shared between the 2 of them. So as long as you know what they look like and how they look like, that's really what matters. So I'm going to jump at number 10 because that's the one Alonzo wanted. And then I think we're basically done with this paper. Okay, so I'm going to redo the work, Alonzo. This is Miss Mapp's handwriting here. She has better handwriting than me, I think. So we're setting up our proportion 7x over 5x, 10x minus 4 over 6x. Right, this is proportionally what we're doing. Now, the biggest struggle you're probably having is, what do I do after I cross multiply? And that's something that you haven't seen in a while from, your algebra 1 days. X times x gets you x squared. 5x times 10x minus 4, well, remember you have to do the distributive property. So I'm going to do 5 times 10, which is 50x, and because it's x times x, that's x squared. Negative 4 times 5 is negative 20. I keep the x. Now, right now, every single one of my terms have x's. So what I'm going to do is move all of my terms to one side. Right now, the 42x squared is one term. It's easy to move one term over to the other side. I don't want to move the right side because then I'm moving too many terms. Oh, that was not pretty. So from here, we're going to go ahead and say 42x squared minus 42x squared. That gets you 0. And it's okay to have 0. 0 is our friend. 50 minus 42, that gets you 8x squared minus 20x. So now we're going to go ahead and simplify this by using the GCF. We're going to factor out a 4x from both of these. When you're factoring out a term, you're really dividing both of them by that number or by that variable, and that's how it gets reduced. So just because I'm dividing it doesn't mean I get rid of it. I'm just using it as a way to help me visually see, hey, 8 divided by 4, that gets me a 2. X squared divided by x, I'm left with 1x. 20 divided by 4, that gets me 5. X divided by x, they cancel out. And so now we're going to do our zero product property. All this states is that if you have 2 things multiplying and they equal 0, one of those things must be 0, either the 4x or the 2x minus 5. Now I'm writing or because this is what we're answering. We're saying either this or this. Now let's go ahead and divide by 4. So x equals 0. Add the 5. Divide both sides by 2. Now you get 2 answers. You have to decide, do I keep both? Do I get rid of one of them? Or do none of them work? Well, luckily for us, right, we have these geometric figures that we can plug our numbers in. If I plug in a 0 into my variable, I'm going to end up with a length of 0 on one side, a length of 0 on another, a length of 0 on another, and then at that 10x minus 4, I end up with a negative 4. I don't know about you guys, but I'm not exactly ready to work with negative lengths here. So that's out of the work. So the only other answer that's going to work is 5/2. That's the only one that's going to give us positive values for our lengths. And that's it. That was a lot of work, y'all. Basically, your whole packet's done. You better know how to do these ones. Boom. Let's take a look at the second one. That one should be the white packet. For this one, because it's already 7:47, I'm not going to be able to spend too much time on this. And I know Liz had a question on one of the other extra credit packets. So let's just say that'll answer 2 or 3 questions from this one. And then that way I can call it a night. Where did 4x come from? Because 4x is the biggest number that I can take from both terms. I'm going to go back to that one real quick. Right, if I look at the 8x and the 20x, 8 and 20, the biggest number I can pull out of both of them is 4. If I use 8, 8 doesn't go into 20, so I can't use 8. The only other factors of 8 are 4 and 2, but 2 is not the biggest one. So I go with the 4. And I mean, technically 1, but every number is factorable by 1. 1's boring. So let's take a look at the second free response packet. See if any of you all have any questions. I didn't really do much on this. I just went over one of the proofs. I do remember that one. Went over both of these. But if anyone needs them done again, I got you. This moment of silence was brought to you by YouTube. Although, how would we get here before 100 million views? That's funny. I don't think I'm ever going to hit that many views. Not even if, what's his name? Yeah, it was the second one that we did. It was the one I'll show you where we did this one. It says free response number 2. That one was kind of like a practice quiz. All right, we'll take a look at number 5, Alonzo, 5A. Okay. Is angle M the right angle or the other one? I don't remember there being a right angle on B. Yeah, M, oh, okay, I see what you mean. M is this angle here. This is angle M. How did I get R? So this was the part where that hint is going to come into play. The angles in the middle pentagon add up to 540. This one can be extra credit. You just don't have to have B completed. In order to get R, you must have everything else and work with the angles, the 180s, the vertical angles, because then once you have that, you'll be able to solve for the rest of your triangle there. I don't want to go too much into detail. I'd rather go through the other stuff. All right, so 5A, A and B are parallel. So that means those are the only ones I can work with. Number 3. Angles 1 and 4 are supplementary. So supplementary means that they add up to 180. So we're probably going to need to use something that's supplementary with parallel lines. Hint, hint, wink, wink. I'm not going to write the given down. That's up to you guys. Well, I know that angle 1 and 2, if we use this line as a transversal, right, then we know that 1 and 2 have to be congruent because they're corresponding angles. Now, if I look at 2 and 3, 2 and 3 have to be congruent because, well, they're vertical angles. And this one is our vertical angle theorem. Vertical angles are congruent. Okay. And then, well, let's see here. If I want to use 3 and 4, right, my goal is to show that they're same side interior angles, then I need to show that they're supplementary. I can't say 3 and 4 are supplementary yet because I don't know the relationship that 3 is to 4. So what I'm going to do here is I'm going to say that based off of our logic here, 1 is congruent to 2, 2 is congruent to 3, so that means 1 must be congruent to 3. And this is our transitive property. Okay. Now that I know 1 is congruent to 3, now I can substitute angle 3 in for angle 1, right? I can literally replace that angle 1. Have a good night, sir. We're going to now say angles 3 and 4 are supplementary. They're supplementary by substitution. And now we can say the lines are parallel. Because now angles or lines M and N are parallel because of the same side interior angles. If same side supplementary, then lines parallel. Cool. I kind of made this one up. I was just like, how can I get these kids to not only know substitution, but transitive at the same time and use the parallel lines to prove that other lines are parallel? It just happened to work out. I had a big brain moment. Sydney, you want to do 3. Isabella, you want to do 11. We just did 5A, Alonzo. Okay, so let's go to, I think 3's on the previous page. Yeah, 3's right there. We'll do that one real quick since we're on a proof kind of mode. So PQ is perpendicular to QS. So that means I must draw in a right angle. RS is perpendicular to QS. So RS, QS, boom, that's another right angle. Before I even finish up this problem, I'm looking at these right angles and thinking, okay, I might need hypotenuse leg depending on what else I'm told, right? So let's see how much more information we're given. T is the midpoint of QS. Here's QS. So T is going to be in the middle. Okay, so based off of what I'm given, I'm probably not going to use hypotenuse leg because I don't have enough information about the sides. I only have enough information about one set of sides. However, we do have our vertical angles that are there too. And we have the right angles. So I know I have 2 angles and one side. So it's either going to be angle side angle or angle angle side. And that's all based on where my markings line up. So right away, I'm going to do my vertical angles. Angle QTP is congruent to angle STR. And this is our vertical angles are congruent. Okay, so I'm going to mark it. Please don't forget to mark it. This is a freebie. Boom. I know that we're dealing with midpoints, so I'm going to mark this segment and this segment congruent. That is QT and ST. Okay, those are congruent because, oh, look, we're using the word midpoint, so we've got to use definition of a midpoint. Or how is angle 1 congruent to angle 3? That is our transitive property. Okay. Okay, so I've talked about one set of angles, one set of sides. I need to talk about those right angles there. So first off, I need to state that they are right angles. And because we're not doing hypotenuse leg, we're not stating that the triangles are right triangles. Instead, I have to state that those two corner angles are congruent. So angle Q and angle S are right angles. This is the definition of perpendicular lines. I guess I could just use the symbol, huh? Definition of perpendicular. Cool. Now that we know they're right angles, because they're perpendicular, now we can say they're congruent. All right angles are congruent. Okay. We've talked about our angles, we've talked about our sides. So now let's mark our triangle. ASA, ASA. So our triangles are congruent by angle side angle. Yay! Okay. Looking good. I think I'll make 11 the last one. Alonzo, I already went over that. Oh, for number 4. My bad. I thought you were talking about the other one. Why is angle 1 congruent to angle 3? Oh, wait a second. Alonzo, angle 1 is not congruent to angle 3. Angle 1 is congruent to angle 4. However, that's not what you're doing on that one. PQ and SR are the only lines that are parallel. So if you draw your Z, then that means only angles 2 and 3 are congruent. You're not using angle 1 and 3. It's 2 and 3. Okay, last one, we're going to do number 11 for Isabella. I did this one, but I'll do it again. Not a biggie. No biggie, Miggy. All right. So right here, Isabella, our top portion of our line, this blue part right here, that length is not given to us, but we were given the 10, which is the total, the X, which is the part. So in general, if you ever want to find a missing segment, it's always the total minus the part. You can do the white packet as well. That'll be another 5 extra credit points. But if you aren't able to finish it, don't worry about it. So then once you have 10 minus X, set up your proportion. So from here, right, we're going to cross multiply. 5 times X, that's our 5X. 7 times 10 minus X, that's 70 minus 7X. So then I'm going to move the 7X that's on the right side over to the left side, and I have to add 7X to both sides. So I'm going to have 12x equals 70. Divide both sides by 12. So then x equals 70 over 12. However, this is not in reduced form. I need to reduce it all the way. Right, so I'm going to divide both of these by 2. So then x gets me 35 over 6. That doesn't reduce any further, so I leave it alone. Yeah, you don't want to have 7x minus 70. That's a big no-no. Big no-no. Okay. It's been almost an hour, and I don't know why I feel a little more drained than usual. I think I might actually be getting sick. Oh, good Lord. If I'm too sick by Tuesday, I may not even be able to get you guys bagels because that would get you guys sick. All right. So here's what I'm going to do. I know Liz had a question on one of the packets. If she can tell me which one it is. I know she said it earlier, but I'm trying to see. She wanted me to do number 8, but she didn't tell me on which packet. Oh, the first packet. Liz, can you tell me what color? Because if you say the first packet, I'm going to assume you mean this one. All right, I just did that one real quick just in case. Yeah, if you guys have any questions, feel free to bug me tomorrow, ask me anything. I'll try to get there a little extra early. No bagels tomorrow, no snacks tomorrow. That'll be on your actual final day, Tuesday, Wednesday, and Thursday. Although I'm only going to be seeing you guys on Tuesday and Wednesday because those are my geometry days. Okay. If and only if there are no other questions, I think I'm going to call it a night. Get some sleep. It feels so late even though it's only 8. Well, I say it's only 8, but definitely going to need some sleep. I hope you all had a good Sunday. You guys, I know you've been working really hard. I believe in you all. You all can do this. Have the courage to seek the wisdom that will grant you the power. You guys are already doing that by being here. So y'all are making me proud. Thank you guys so much. Y'all have a good night and stay cool and get plenty of sleep. You guys will need it, okay? Take care. Bye.